Hello everyone, in this video we are going to see numerical analysis, and here I have written the syllabus for the CSIR NET examination. Now we see what is meant by an algebraic equation. If I have some polynomial f of x and if it has some root x naught, then I can say that that polynomial is called that polynomial is have been written as an equation like f of x equal to 0, and that is called algebraic equation. Now, what is meant by a transcendental equation? A transcendental equation is an equation which involves some functions like this sin x cos x, and here I have given some example of algebraic and transcendental equation. Now we all know what is meant by the intermediate value theorem, right? Which we have studied in our real analysis. Like if my function f is continuous in the interval, some interval close the a comma b, and if that f of a is less than 0 and f of b is greater than 0, or else f of a is greater than 0 and f of b is less than 0, then I have some root lies between a and b. It's like if my f is a continuous function and here is a and b, then f of a should be here and f of b should be somewhere here. Then there is some x such that this function f of x becomes 0. So this x is the root and it lies between a and b. This is what intermediate value theorem says. So if you want to locate some root of the equation f of x equal to 0, we shall use intermediate value theorem. Okay, now we are going to see what are errors in numerical computation. First, we see what is meant by an absolute error. If alpha is an approximate value of a quantity whose exact value is a, it's like you want to get 2, but you have some 2.5233. Then 2.5233 is that approximate value and 2 is that exact value. Then the difference epsilon, that is that 0.5233. That stuff is called the absolute error of alpha, or simply the error of alpha. It's because I have to get 2 right, but I am having 2.5233. So that quantity is 0.5233. That is called the absolute error of alpha. And I have something called relative error. A relative error is nothing but the absolute error divided by the exact value. Okay, provided a is non-zero. And I have something called percentage error. A percentage error is nothing but relative error multiplied with 100. Now we have something called correction. That is nothing but our minus epsilon. It's like I'm having 2.5233 instead of 2. So my correction will be what? 2 minus 2.5233. So that minus 0.5233, that stuff will be the correction. And if I add that correction term to my approximate value, I will get the exact value. It's I'm having that approximate value as 2.5233 and my error term is minus 0.5233. So I am subtracting it, so I am getting 2 as my exact value. So true value equal to approximate value plus correction. Now I have something called experimental error. An experimental error is an error which is present in the given data that may arise from measurements. It's like I am doing some experiment with screw gauge and I am measuring it with some flaw. So that may be called as experimental error. And now I have something called truncation error. Truncation error is something like if I have to do like 5 steps to get some exact approximate value, but I am stopping it to in the second step itself, I will get some error there, right? That is called truncation error. Yeah, so they are given that the sequence of computational steps necessary to produce an exact result is truncated after a finite number of steps. So I am truncating the experiment after finite number of steps, computation after finite number of steps, and I'll get some error that is called truncation error.